Okay, we're back. New screen recording. I'm going to go ahead and call up. Oh, I was going to introduce the scientific mega, but we're not quite ready for that yet. So this is just part one. So this will be a little part of part two. So let's go ahead and here's a little slideshow that I've got going. I don't know if I'm still showing up in the corner of your screen or not. This is actually the intro to my Physics 210 class from a few years ago. It's changed a little bit, but no worries, no worries. Anyway, so here's who I am, and if you want to email me, you certainly may if you're watching this. And here's here's this is also from my physics of sports, and here's a deep scientific question. Is it now? This is from quite a while ago, from 2008. So that's 12 years ago. Thinking about that, you all were in like second grade when this movie came out, and I still think it was made yesterday. But Quantum Hoops is, I teach a class called Physics of Sport, and I'm always wondering is there's kind of this idea out there that scientists and sports really don't mix too much, which is not true. There's some very good athletes that are that play sports, and there's some very good. There's some many scientists that play sports and do it very well, and they tend to gravitate though. My colleagues tend to gravitate towards individual sports like distance running and things like that versus team sports, which is kind of funny because science you have to do as a team a lot of times. Maybe it's because they're tired of collaborations and just want to get away. Plus, hey, they're not the most outgoing. How do you know when a physicist is a extrovert? He'll look at your shoes when he's talking to you. Anyway, so how does physics and basketball actually mix? And this is from a movie from Caltech, a university that has produced 31 Nobel Prize laureates, that is probably the top physics institution in the world. It's got an endowment out the wazoo and everything else. But their basketball team back in the early 2000s, well, here you go. Let's just take a peek. Oh, wait, I need to go to slideshow.
Imagine playing a full basketball season and not winning a single official game. That's bad. Now imagine doing that for 21 straight seasons. That's brutal.
Air ball, and it hits cheerleaders behind the basket. 80-46 is our final score.
With liquid nitrogen, you could do a lot of things that are quite fun.
Number of valedictorians on the team this past year was 8. The number of players that played high school varsity basketball was 6.
I knew the streak coming in, which made me confident that I could play on the team.
Chris, on the chalkboard there, wrote, "You may have beaten us, but can you solve this integral?"
After that, I started writing it on every chalkboard.
A lot of people on the inside here have said this is impossible. You can't make this better. You can't have some level of success. In fact, you can't have some level of success, but you can't have any success whatsoever.
It's the incredible true story.
Someone in the stands was yelling, "Hey, shouldn't you be doing homework right now?" Well, yeah, I actually do need to.
Of the world's smartest basketball team.
My life would have been a lot worse here if it wouldn't have been for basketball.
Who have one last chance
To do
the impossible.
How many of these kids were standout basketball players in high school?
None of them were standout players.
Just a shock that he's able to change the culture so much that those kids are really believing they have a shot.
Part of what they do here is let the rest of the world know why things are not impossible.
And whoops, I'm going the wrong way. Uh-oh. Now I'm in trouble. Here we go. Back here. Now this is the screen where I'm making the slides. So anyway, I just thought that was a, so let's go with it here. Oh. All right. There we go. So what is physics? So here's the next slide is what is physics? Physics is the, and science in general is the of the very large to the very small, okay? And then we might ask ourselves, well, what is the scientific questions that we ask? What are we actually studying? We don't need to go through all the units and all that stuff. This is pretty good too. We'll talk about the units, but what do? In science, we ask a question and then we take measurements to validate, to see if it's true, or to see where it takes us. And here's the reason we're doing this is because it's based on the kilogram, how much mass. And remember, there's a big difference between weight and mass. You can still have mass, but be weightless, right? As is proven here. And this is the astronaut training thing. Oh, video is unavailable. Good. We'll show it later. All right. So here we go. Let me stop this now before I get into any more trouble. And we'll just call this the part 2. And the next thing is we will show the asking a scientific question. Then I have a little project that we can do together.